Okay, for cluster validity, um, we will look into a variety of measures to evaluate how good our model is. So basically, we are looking at the compactness and the separation value for the cluster. Okay. If we compare with supervised classification, we are looking at the accuracy with the precision and recall. So these are the metrics that they use to measure the quality of the classifier. But for the cluster analysis, how do we perform how do we evaluate the performance of the clustering technique? We will look into that one in this one. Okay, so the purpose of evaluating the cluster analysis is to avoid finding pattern in noise, to compare the clustering algorithm, and also to compare two set of cluster. For example, three cluster is better or not compared to five cluster. Okay, so we want to compare which one is better, three or five cluster. This one to compare two cluster. So between two cluster, which one is good? So in this one, we are looking at the compactness only. Okay, so we have a few measure of cluster validity. The first one is called external index. So external index, they are referring to the cluster entropy. So this one, they are looking at the content of your cluster. And the internal index, they are looking at the structure of your cluster. Okay, so the differences between external and internal is that external, they look at the content, how genuine is your cluster. Okay, for the internal index, they are looking at the structure of your cluster, how compact they are, and how far they are separated. Okay? And the third one is relative index, used to compare two different clustering or cluster. So this is sum of square error or the entropy. So it could be sum of square error or the entropy. So we will look into this tool. Okay. Okay, you have studied about entropy, so we will apply the same concept here. We are looking at how um, how pure is the content of the cluster, or how pure is the membership in one cluster. So basically, we are looking at the number of cluster here, and then this is the entropy for each of the cluster, and this is the weightage of that particular cluster. And then the entropy is defined as the summation of probability that we get all the classes that we have. Okay, so we have studied these two. Look at this example. So we have for cluster one, we have A, and then B, B. We only have two B here. Okay. So what we will perform here is that we will evaluate the cluster based on the content of the cluster, the membership of the cluster. Okay. Take a look at the first cluster. Okay, the first cluster. The first cluster we have 5A and then 2B. So this is looks familiar, huh? So this one is the entropy for this cluster. And then for this one we have 1B, 1A, 1B, 1B, and 7C. So 1/9, 1/9, and 7/9. Last one we have 1B, 1A, 2B and 4C. So 1, 2, and 4. Okay. So the total entropy for your all cluster will be, remember that this is the weightage that we have for cluster 1. So we have 7 divided by 23 because we have 23 items for the whole cluster that we have. And only 7 belong to cluster 1. Okay. So this is the weightage for cluster 1. Cluster 2, the weightage will be 9 over 23. And the weightage for cluster 3 will be 7 over 23. So this is how you compute the quality of the cluster based on the content. How pure is the cluster? Okay. 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 The second one is more difficult to understand, but we will go one by one. So basically, the, they call it Davis Boolean index because these two guys invented this benchmark. So basically what we want to do is we want to look at the compactness of each of the cluster that we have and then the distance between these two clusters. And we will do it for all the cluster that we have. Okay. So for Davis Boolean index, we are looking at the compactness and also the distance between two clusters. And in order to find the compactness of the cluster, we first have to find the centroid of your cluster. So this is the formula. So basically, we are looking at the no. This is the average intra distance. So basically, this is how compact is your cluster. So this one is the compactness of your cluster, because they are measuring all the member in that cluster to the center. How do you find the center? The center is here, which is you sum up all the value uh, in the vector and divide by the number of membership in that cluster. Okay, and the distance between two cluster can be measured by looking at the differences between the first cluster and the second cluster. Okay, so I will illustrate one example on how we can apply this formula. Okay, okay. Let's suppose we have this cluster. Okay, and these are the value that we have for cluster 1, cluster 2, and cluster 3. And these are the attribute that we have for our data. Okay, so that means this is the first record, the second record, the third record belong to cluster number 1, and so on and so on. Okay, so the first thing that you need to do is you need to find the centroid of your cluster. How do you find the centroid? You add up all this value and divide by 3 by the number of item of that particular cluster. And all these 3 will be your centroid. Okay? Any question? Okay. So next one is that once we have found the center of the cluster, then we can compute the compactness of the cluster. Okay. So we found this center, and this center. Now we want to find the distance between all the member to the center. Okay. So how do we find that one? Um, okay. For this one, we compute the distance between the cluster first. We can do this one first, or we can find the compactness. But in this example, we are looking at the distance. the distance between C1 and C2, the distance between C2 and C3, and then C1 and C3. Okay, so the distance between Q1 and Q2 will be just looking at the differences between these two. So 1.83 minus 3.5 square, 2.83 minus 0.67. Okay. Um, let's take a break first. 5 minutes. Okay. We take a break 5 minutes. Okay. So for okay. For this example, we are looking at the distance between each of the centroid. So we look at the distance between Q1, Q2, Q1, Q3, and Q2, Q3. Okay. So basically, we are looking at the differences between these two, and then this, and then this. Okay. So that's how we find the distance between the centroid. Okay. So in the first phase, we are looking at the finding the center. The second phase, we are looking at the finding the distance. And then the third one will be looking at the finding the compactness of each of the cluster. So for example, like this, the first one measure the compactness of the first cluster. So basically we are looking at, we take this, the center, and then take the differences from all these record and then sum up them together and take the square. Okay. So so basically we take 2 minus 1.83 and then 3 minus 2.83 and so on. So we get all the calculation. So this is the compactness of cluster 1. We repeat for cluster 2. So meaning that we are looking at the differences between these two, all these members. And take the square root, we get 0.43. And then for cluster 3, we have this. Okay. Okay, now we have all the value that we wanted to have. We have the compactness of the cluster. We have the distance between two centroid, between two cluster, and also we have the center. Okay, now we look at the formula here. The formula here saying that I will go from cluster 1 up to C. Okay, in this case, we have C equal to 3. Okay? So what I will do is that, okay, now, okay, I'm taking this one, and then I will compare with the C2 and C3. Okay, so first I will compare with this. The formula that we are looking at here is that the compactness of cluster 1 and also the compactness of cluster 2 and the distance between cluster 1 and cluster 2. Okay, we have all the values computed earlier, so we just plug in, and for C1 and C2 we have 0.38. Okay, and now I'm doing it for C1 and C3 again. Okay, and I plug in the value. This is for Q1, Q3, and then the distance here, and this is the value that I get. Okay, so since I'm using max here, so basically I'm choosing either this or this value. But since this is max, I will choose this one. In this case, we take the worst scenario. The worst scenario, so the worst, that's why we are looking at the max. Okay, so this is the first part, only for cluster 1. So cluster 1 has this value. Now I'm doing it for cluster 2. Look at the color of the cluster. Okay, now I'm doing it for 2. So that means I will do it for Q2 and Q1 and also Q2 and Q3. Okay, so this one I get 0.38, and then for Q2 and Q3, I take the compactness of cluster 2 plus the compactness of the cluster 3 divided by the distance between cluster 2 and 3. Then I get this. Then in between this, I find the maximum. The maximum will be 0.38 lah. Okay, so the next stage will be 3. So I will do this with this again and that. So C3 and C1, which is this one. So I take the compactness of this cluster 3 plus compactness of cluster 2, 1 divided by the distance. And then I get this value. And for cluster 3 and 2, I get 0.2. And then between this, maximum will be 0.29. Okay? So the final dBi value will be, we will take the average. This is 3, kan? So we will take the average of all this summation. So we get this. Okay? So remember that the distance here we want to maximize. And the compactness here we want to minimize. Okay? So basically, based on this formula, we are saying that the smaller is the value of the dBi, because you want to maximize bawah ni and you want to minimize yang atas ni. So the lower is the dBi value, the better is the quality of your cluster. Okay. Okay. Any question? Okay. The time is 3:22 already. I think I will stop here.